The evolving landscape of logistical solutions is explored, with a focus on the transformative impact of autonomous drones on contemporary delivery networks. How these innovative aerial vehicles are poised to redefine efficiency, speed, and accessibility within various industries is considered. Imagine a world where your packages arrive not by truck, but by silent, swift drones right to your doorstep. What if I told you that future isn't far off, and it's set to revolutionize how everything gets delivered? Get ready to explore the incredible ways autonomous drones are already transforming logistics, from urban centers to remote communities. Current drone delivery efforts focus on limited commercial operations and trials, largely driven by regulatory advancements and targeted applications in healthcare and last-mile retail. While some companies are testing larger cargo drones, the current commercial market primarily handles small packages, often in specific geographic areas. Delivery of medical products is one of the most prominent and impactful applications of drone technology today. Drones can bypass geographic barriers and traffic congestion, dramatically shortening delivery times for critical and sensitive supplies. This company is a global leader in medical drone delivery, with extensive operations in Rwanda and Ghana to supply blood, vaccines, and other essential medical products to hard-to-reach clinics. The Indian Council of Medical Research has successfully used drones to deliver critical vaccines, medicines, and surgical equipment in challenging terrains across India, including the Himalayan region. Operating in Africa and the Pacific Islands, this company delivers health supplies, including vaccines, to isolated locations. During the COVID-19 pandemic, it became the first company to remotely pilot commercial drones from another country. This company has delivered laboratory specimens and medical supplies at Edmonton International Airport and Halton Healthcare in Canada. Major retail and logistics companies are actively trialing drone delivery for consumer goods, focusing on speed and efficiency for last-mile logistics. Drones are increasingly being used for fast delivery of meals and groceries, particularly for orders that are small, lightweight, and time-sensitive. In India, online grocer Big Basket and drone logistics provider Sky Air Mobility have partnered to deliver groceries in apartment complexes in Bengaluru. Traditional postal services and shipping companies are exploring drone technology for increased efficiency, especially for deliveries to remote locations. While significant progress has been made, large-scale drone delivery still faces hurdles related to regulations, airspace management, battery life, and public perception. However, advancements in AI-driven navigation, improvements in battery technology, and the growing demand for faster, more sustainable delivery options suggest that commercial drone delivery will continue its expansion in the coming years. Drones are transforming emergency response and relief efforts by providing speed, safety, and access to remote or damaged areas. Equipped with advanced technologies like thermal cameras, AI analytics, and long-range capabilities, drones can perform vital tasks that are risky or impossible for humans. After a natural disaster, drones provide rapid, real-time aerial footage that gives first responders and authorities a complete picture of the affected area. Drones are an indispensable tool for wildfire management, providing a vital aerial perspective. An advanced drone delivery ecosystem requires a complex infrastructure of ground-based assets, automated systems, and air traffic control. This network goes far beyond just drones, relying on sophisticated landing pads, charging stations, and a specialized unmanned aircraft system traffic management (UTM) system to ensure safe and efficient operations, especially in urban environments. These hubs address the limited flight range of drones. Instead of returning to a central depot, drones can land at a nearby charging station to either wirelessly recharge or automatically swap their depleted batteries for a fresh one. To operate drones safely at scale, particularly beyond visual line of sight, BVLOS, a specialized traffic management system is required. This system is known as UTM and is separate from, but complementary to, traditional air traffic management, ATM, for manned aircraft. AI and machine learning, ML, are transforming logistics and delivery management by providing dynamic and intelligent solutions for route optimization and obstacle avoidance. Unlike traditional systems that rely on static, historical data, AI-powered platforms can process massive datasets in real time, adapt to unforeseen disruptions, and continuously learn to improve efficiency, reduce costs, and enhance customer satisfaction. Companies like Amazon and Farai have developed proprietary AI routing engines to gain a competitive edge. These engines are specifically tuned to handle real-world challenges unique to their business models, such as managing high order volumes in dense urban areas. For connected logistics, 5G's high speed and low latency enable real-time communication between vehicles, fleet management systems, and cloud computing resources. Innovations in software and hardware are deeply intertwined, with each driving the other forward. The following are some of the most complex and significant innovations in both fields. Tools like GitHub Copilot use generative AI to assist developers by suggesting and automatically generating code snippets, automating repetitive tasks, and streamlining debugging. This marks a shift from developers manually writing code to training machine learning models to generate software solutions. The focus moves from hand-coded logic to curating and optimizing datasets for models to learn from and generate code.ai. This refers to AI that can operate with little to no human intervention. These AI agents can act on their own, performing tasks based on a given prompt or objective. As businesses adopt multi-cloud strategies using multiple providers, software innovations focus on enhancing resilience and portability. The main regulatory and airspace management challenges for widespread drone adoption are developing effective unmanned aircraft system (UAS), traffic management (UTM) systems, standardizing licensing and compliance, and ensuring public safety and data privacy. Solutions include implementing real-time tracking technology, harmonizing regulations, and fostering public-private collaboration. Existing air traffic management (ATM) systems were built for manned aviation, safely integrating thousands of drones, which operate at lower altitudes and with different flight characteristics, requires a completely new approach. Drone operators and air traffic controllers often lack a comprehensive, real-time picture of all aircraft in the airspace, both manned and unmanned. This inadequate situational awareness increases the risk of collisions. Public perception of noise pollution is often complex and contradictory, with people recognizing its negative health impacts yet tolerating it as an unavoidable part of modern life. In urban areas, the primary sources are typically traffic and construction, which diminish residents' quality of life and infringe on their sense of privacy at home. When releasing environmental monitoring data to the public, the data should be aggregated to prevent the identification of specific individuals. Instead of microdata, which links to specific physical measurements, macrodata presenting aggregated information is preferable. Educating the public about the severe health and privacy impacts of noise pollution can empower communities to advocate for change and participate in solutions. A robust legal framework with clear, enforceable rules regarding acceptable noise levels is crucial for protecting the public's right to peace and dignity. Emerging drone technology focuses on enhancing safety, reducing noise, and providing secure delivery. Innovations include advanced sensor technology, quieter propulsion systems, and secure, designated package lockers. Ground-based infrastructure, such as DroneUp's DBX unit or Strixdrone's drone drop mailbox, offers a secure, climate-controlled locker for package retrieval. The drone lands on the unit and places the package inside, which can then be accessed by the customer with a unique code or app notification. Some systems require the recipient to scan a QR code or AR tag upon delivery, creating an authenticated chain of custody. Innovative systems, such as one developed by Jedzi, use a stable, custom mailbox installed at a window or balcony. This allows drones to land and drop off packages without needing ground-level access. The final step of delivery requires secure methods to prevent theft and protect packages from the elements. Autonomous drones will revolutionize e-commerce by accelerating last-mile delivery, offering faster, cheaper, and more efficient services that bypass traffic, reduce carbon emissions, and improve accessibility, particularly for remote areas. Challenges remain, including regulatory hurdles, data privacy concerns, safety issues like mid-air collisions, infrastructure needs, and customer acceptance, but continued technological advancement and real-world implementation are steadily paving the way for their widespread adoption. The impact of advanced technology on specialized industries is transforming operations through increased efficiency, safety, and data-driven insights. For agriculture, this means precision spraying to reduce waste and improve crop health. For construction, it involves comprehensive site monitoring to optimize projects, and for disaster relief, it is enabling rapid, targeted aid delivery. The drone delivery sector has significant potential for new business models and job creation, but it is still developing and faces various challenges. It is poised to revolutionize logistics by offering faster, more efficient, and eco-friendly last-mile delivery, especially in urban, rural, and remote areas. Startups and tech companies can offer specialized drone services to larger retailers and logistics companies. This includes fleet management, technology, and operations, enabling established businesses to adopt drone delivery without massive upfront investment. The shift toward drone delivery will create new, high-skilled jobs while displacing some traditional roles in the delivery sector. The rise of automation could lead to job displacement for some traditional low-skilled, low-paying delivery and courier positions. Existing logistics workers may need to be retrained for new roles, such as drone fleet management or ground support, to adapt to the evolving industry. While a precise timeline is difficult to predict, widespread and routine autonomous drone delivery services are expected to roll out regionally in the late 2020s, expanding significantly between 2030 and 2035. Market growth will be gradual and uneven, accelerating as technology, regulations, infrastructure, and public acceptance evolve. The next few years will see major expansion of existing drone delivery operations. Companies like Amazon, Wing, and Zipline will continue to build upon their current pilot programs and partnerships, delivering items such as food, groceries, and small packages. Although long-term costs are expected to be lower, the high initial investment in technology and infrastructure requires continued significant investment from logistics companies and venture capital. A supportive infrastructure, including a network of drone ports, charging stations, and package terminals, is required to manage a high volume of drone traffic efficiently. Envisioning smart cities integrated with drone logistics involves creating a seamless, automated, and sustainable urban ecosystem where unmanned aerial vehicles, UAVs, work in tandem with ground-based infrastructure. This system promises to address critical urban challenges like traffic congestion, pollution, and inefficient last-mile deliveries. To inspire viewers to contemplate the profound implications of evolving technology, present a compelling call to action that balances excitement with responsibility. The following options can be adapted for a video's conclusion: an exhibition display, or a presentation. Every innovation has the power to uplift or exclude. As this technology advances, let's ensure it serves all of humanity, not just a privileged few. Support initiatives that promote digital literacy, advocate for accessible design, and champion equitable access to technology. The future is inclusive, but only if we make it so. Rapidly evolving technologies, particularly in artificial intelligence, AI, present both transformative opportunities and complex challenges for society. It is essential for every individual to move beyond simply observing these changes and to actively engage in the conversation about how they will shape our future. As you develop new technologies, take time to think critically about their real-world impact. Consider not only what your creation can do, but also what it should do, and how it might be misused. Demystify the technology you are building. Explain its purpose, limitations, and potential ethical dilemmas in plain language so the public can understand what is at stake. Ensure that the technology you create is accessible to everyone, not just a tech-savvy few. Actively seek out diverse perspectives to avoid replicating or amplifying societal biases. Every person has a role to play in shaping it. Your curiosity and your engagement are the most powerful tools you have.